Hello friends, I hope you are well today. Let me welcome you into MJ School of Mining and Geology YouTube channel. Thank you guys for tuning in today. Your support is highly appreciated. The main question we'd ask ourselves today is, are you facing a problem in grasping the concept of unconformities in geology? If so, stay tuned to know more about what is an unconformity, its types, and its significance in geology. But wait, before we continue, please don't forget to like, share, comment, subscribe, and hit the notification button to be notified once we upload new content. Let us get right into today's topic. So basically, an unconformity it is defined as a period of non-deposition, a period defined by the deposition which stopped for a moment. Also, it's a period of non-deposition. That is to say, a period at which a deposition stopped for a moment, or you can define it as a period of erosion. That is to say, if for example, when we say according to Nicholas, which came about with what you call the principles of stratigraphy. One of the principles of stratigraphy is original horizontality. So which says that the layers are deposited horizontally in all directions. So when layers are deposited horizontally in all directions, we say that is what you call conformity. It means the layers are conforming, they are agreeing with each other. All right, so this unconformity is the opposite of what is happening. So when we saying unconformity, it means the layers are no longer agreeing with each other. For example, if we count from 1 to 5, 1, 2, 3, 4, 5, it means these numbers are conforming, they are agreeing with each other. But the minute you say 1, 3, 4, 5, something is missing, 2 is missing. It means these numbers are no longer agreeing with each other, they are no longer conforming with each other. Then something is missing. Whatever that is missing in geology, it represents a period which is defined by erosion. It's a period of erosion or a period of non-deposition. That is to say, a period wherein deposition has stopped for a moment. But remember, in geology, we are talking about many number of years. All right, so and then until new sediments need to be deposited with time, which are younger. All right, so like I said, unconformity is just a break in time in an otherwise continuous rock record. It's a break in time or a period of non-deposition or a period of erosion. All right, so what's happening is we're having some layers which are older, which were deposited first, and then part of the layers that they get to be eroded, and then new sediments that get to be deposited on top. It means the layers which are deposited on top are younger, and the ones which were deposited first and get to be eroded, they are older. And then that boundary between younger and older sedimentary layers, it is called an unconformity. All right, so unconformities are a type of geologic contact, a boundary between two rocks caused by a period of erosion or a pause in sediment accumulation. All right, and then followed by the deposition of sediments anew. It means you either have to have layers which were eroded, and then new sediments that get to be deposited on top. All right, on top of the eroded older sedimentary layers. So basically, that's unconformity is all about a period of non-deposition or a period wherein the sediment accumulation was paused a bit, and then new sediments get to be followed, which were deposited on top of the older eroded sedimentary, or it could be igneous or metamorphic rocks. Okay, so that is what you call a gap, and in sediment deposition. All right. So this is a typical example of what an unconformity is. The layers are no longer conforming. All right. So here it's a typical example of what you call the angular unconformity, wherein the top younger sedimentary layers are deposited on top of tilted and eroded older rocks. That is a typical example of what an unconformity is all about. All right, and then this boundary which separates this top younger and bottom older rocks is what you call an unconformity. This represents a gap wherein there wasn't any deposition, okay, or wherein the deposition has been stopped, or it stopped for a moment. All right, yes. So, or a period of erosion. That is to say, for example, with angular unconformity, we see firstly the rocks were deposited initially. They were deposited horizontally, and then they were affected by the tectonic deformation, meaning they were folded. After being folded, they get to be eroded, and then they're still tilting, and then new sediments are deposited on top of that, eroded on top of that tilted and eroded surface. And then that's an example of what an angular unconformity is. So yeah, so we know, according to Nicholas Steno, which came up with what you call the principles of stratigraphy, we say if the layers are conforming, it means they're agreeing with each other. So according to the original horizontality, it means the layers were deposited horizontally in all directions. All right, but now and then these layers will chronologically follow each other, wherein the layers at the bottom will be older than the layers at the top, provided these layers, they are not affected by tectonic deformation. But with time, if these layers which were stratified initially, they're affected by tectonic deformation, they will be tilted. So tilting will always come later, but initially what comes into our mind is the rocks were deposited horizontally in all directions. So this concept, it will help you especially to understand the angular unconformity, to know that first step or initially, if we close our eyes and think what could have happened 10 billion years ago, we would say, okay, sure, we know that originally the layers must be deposited horizontally in all directions unless they get to be tilted. So if we see them being tilted, it means they were affected by tectonic deformation. So we say unconformity, it's a gap which is represented by a period where there was no deposition, or deposition was it has paused for a moment. All right, or it's a period of erosion. All right, so it means if we see the older layers which were eroded, and then we would have an erosional surface, and then on top of that erosional surface we would have new deposited younger sedimentary rocks. All right, and then this happens due to tectonic movements or tectonic deformation, that is to say folding in this case. And then obviously if rocks are folded, they're gonna be buckling up, and then they get to be, if they are not buckling up, sometimes they can go a bit downward, and then new sediments will be deposited on top. All right, and then this is a break in sedimentation, wherein all the sedimentation stopped And then later on, it will continue wherein now new sediments, which are now characterized by their own physical and chemical characteristics, will be deposited. And remember, if we have got layers which are defined by their own physical and chemical characteristics, it means that in itself it will tell us much about the environment of deposition. So when we see some rocks, we see let's say colors, we see their roundness, their sphericity, their grain sizes, and many other physical characteristics, and of course their chemical characteristics. And then what comes into our mind is we close our eyes and think back some 10 billion years ago about the environment of deposition. So that is what you call the break in segmentation. All right, yeah. So horizontal or conformable strata or beds are formed according to Nicholas Steno, which says the rocks are initially deposited horizontally in all directions until they're affected by what you call tilting or tectonic deformation, or they're being tilted. So we've got 4 types of unconformities. We've got angular unconformity, which I've already touched. That is to say, we've got angular unconformity. We've got the layers which were originally deposited horizontally, then they're affected by tectonic deformation, then erosion comes, and then a new younger sediments will be deposited on top of the tilted and eroded surface. All right, and then disconformity and paraconformity, they are one and the same thing. And then there's just one thing which you can pick for you to be able to differentiate between these two. That is to say, with the disconformity, you'd have an apparent erosional surface, but with paraconformity there is no erosional erosional surface, apparent erosional surface. That is to say, in simple terms, the disconformity you will see it with irregular boundary, all right? But with paraconformity, the boundary is just parallel, it's not regular. So paraconformity is not easy to notice it with your own eyes, and then for you to be able to notice the boundary, you can have an additional information using what you call fossils. All right, so yeah, that is the difference between these two. So on the other hand, non-conformity, it's the simplest one. You can have either igneous or metamorphic rock, and then those igneous or metamorphic rocks which are older, they get to be eroded, and then after having an erosional surface, we have new younger sedimentary rocks which are going to, or sedimentary layers which are right on top of the older eroded igneous or metamorphic rocks. So basically these are the types of unconformities, but I'm going to show you with examples or with some pictures so that you can be able to visualize what I am talking about. So moving right on, I'm sorry about the pause. I don't know what is happening. Okay, I think it's back. Yeah, so as we can see, like I said, the difference between these disconformity and paraconformity, in simple terms, disconformity and paraconformity, they look alike. That is to say, they've got things which are common. That is to say, all their layers are parallel. The only difference is with disconformity, we've got an erosional surface which is irregular, and it's easy to be seen, to be noticed with our naked eyes. But with paraconformity, the erosional surface is not easily seen. All right, so it's not irregular, it's regular, or it's parallel, straight. All right, so it means for you to notice this boundary, you have to use additional information. That is to say, you have to use fossils. All right, and then but non-conformity, you can have igneous or metamorphic rock, any rock as long as it's not sedimentary rock and it's older, and then that rock needs to be eroded and then create an erosional surface. Then new sediments which are going to be deposited horizontally conforming, and then they're going to be deposited on top of the eroded igneous or metamorphic rock. All right, but now with an angular unconformity, we have to have sediments which were initially deposited horizontally, and then they were affected by tectonic deformation. They were tilted or deformed, okay, folded, that is to say, and then after that erosion takes place, and then we have tilted and erosional surface, and then the new sediments are going to be deposited. New sediments which are younger will be deposited on top of the tilted and eroded surface. So basically that's examples of these unconformities. So this is just to emphasize my point, that is to say, you can see we have got igneous rock here, and then this igneous rock, it was eroded. It was eroded, and then now new younger sedimentary rocks were deposited on top of the older eroded igneous rock. That is example of what you call non-conformity. Okay, the layers are no longer conforming, they are no longer agreeing with each other. All right, yeah. And then this conformity, on the other hand, like I said, it's like a paraconformity. They've got the common thing, that is to say the layers are parallel. All right, the layers, they are parallel, they are well stratified, but now it's easy for you to see an erosional surface. It's easy for you to see this boundary because it's irregular. It's easy for you to see it. All right, yes. And then this is still an example of this conformity. Can you now see we've got this an erosional surface which is easy to be seen with naked eyes. All right, it's easy to be seen with the naked eyes. All right, so we're still talking disconformity. We've got this bumpy or irregular contact between older and younger sedimentary rocks. But on the other hand, paraconformity refers to the type of unconformity where in the upper, young and old, lower rock layers or masses have the same orientation. That is to say, they are all parallel. They are parallel with little or no noticeable erosional features or noticeable erosional surface. It's not easy for you to see that, especially with your naked eye. Okay, so therefore it's hard to recognize or discern as rock beds appear as conformable. No, it means now those layers, they all agree with each other. Remember, it's like you saying 1, 2, 3, 4, 5. Then count it again. 1, 2, 3, 4, 5. I don't see any mistake here. It means these numbers are conforming. All right. So, but they are in actual fact, they are not conforming. They are not agreeing with each other. But now, how will you be able to pinpoint the period of non-deposition or a period of erosion? You can only do that with a high amount of certainty using what you call the fossils. Okay, so the only way to recognize a paraconformity is by considering the age of the upper and the lower rock strata. One such method is using fossil records. Okay, so I hope it makes sense now. Okay, so as you can see now, these layers are conforming, they are agreeing with each other. It's not easy for us to know or to recognize the boundary between the top younger rocks from the older bottom rocks. It's not easy. It means these layers are parallel, they are conforming with each other. All right, so for us to be able to recognize that boundary with a high degree of certainty, we have to use the fossils. All right, so which is why we're saying the difference between paraconformity and disconformity is with paraconformity, the the erosional surface is not easily noticeable. It's straight, all right, but with this conformity we've got this irregular erosional surface. Okay, so the difference between paraconformity and conformity. So both these unconformities have strata parallel to each other. It means the layers are parallel to each other. All right. So, but with this conformity, we've got an apparent erosional surface to help identify it. That is to say, you see, it's easy for you to see that because it's just irregular erosional surface. But now with paraconformity, there is no irregularity. That is to say, the contact is just parallel. Okay, it's parallel with it's parallel to the rock layers, so it's not easy for you to identify the gap or to notice the gap. Then now, or the erosional surface. Then now, to do that, you need to use what you call fossils. So then unconformity, like I said, now can you now see that the top part, this top part, new younger top sedimentary rocks are being deposited on top of tilted and eroded older sedimentary rocks. That's basically what an angular unconformity is all about. All right, but basically now remember, according to Nicholas Stinnes, who came with what you call conformity or original horizontality, which states that the rocks were, or the sediments were deposited originally horizontally in all directions, right? And then until later on, wherein they were affected by tectonic deformation, they get to be folded, and then after being folded or uplifted, and then they would now undergo what you call erosion. Then after being eroded, and then new younger sediments will be deposited on top of eroded and tilted surface. That's what angular unconformity is all about. Okay, so to make you understand even more, first stage one, we've got now the sediments which were deposited horizontally in all directions. They are undisturbed, they are stratified. All right, and then once these layers are undisturbed, then the principle which is known as what you call the principle of superposition, it's applicable now. That is to say, and the principle of superposition can only hold if the layers are stratified, they are undisturbed. Then now you can now say with confidence that the layers at the bottom are older than the layers at the top. But now with time, the tectonic deformation, that is to say folding, came into picture, now uplifting these layers, and then now they are uplifted like that, or they are folded like that, they get to undergo what you call erosion. And remember, they're still folded, they're still tilted. Okay, they're still inclined. And then now deposition take place. Then new sediments, new younger sediments will be deposited on top of the tilted and eroded older sedimentary rocks. Then that in itself, it brings the name an angular unconformity. All right, yes. Then if you can check on your right hand side, you can now see that, okay, we've got, you see these layers which were deposited, which are inclined or which are tilted, and then new younger sediments are deposited on top of this tilted and eroded older sedimentary rocks. That's an example of what you call angular unconformity. So in conclusion, unconformities, they are very helpful. For example, you will not be able to correlate rock layers if you don't have a bit of knowledge of what you call unconformities. Right? So for you to be able to say, oh, okay, we see this pinching here, or these things that are no longer conforming with each other. For you to be able to do that, you need to have a background of what you call unconformity. So it means you will not be able to easily correlate if you don't have a background of unconformities. All right. And then other things, including lateral fasces. Lateral fasces. Remember, Jonas Walther says that the what can be seen lateral can also be seen vertically. So and to be able to interpret the lateral fasces, you also need the knowledge of unconformities and also changes in sea level. That is to say, transgressions and regressions. So if you haven't yet visited our videos about our video about transgression and regression, changing sea level, which also affect what you call the fasces. So please visit that. You'll learn a whole lot about transgressions and regressions, that is to say, changes in sea level. All right. So, and also by reconstructing paleography, all right, for you to understand the past environment, you need to understand or have a background of unconformity. Okay. And also determining the timing of tectonic activity, or determining the timing of tectonic activity to exactly when the tectonic activity happen or will happen. All right. So, ladies and gentlemen, thank you so much for joining us today. We really appreciate your support. Please don't forget to subscribe, to like, to share, and to always hit the notification button so that you get to be notified every time we upload new content, so that you are always in par with our content. Your support means a whole lot to us. Please keep on supporting us. Please give us some comments so that we know where to improve. Thank you so much for joining us today. Until next time, cheers.